My name is Grete Irene Solvold, and I'm an archaeologist at NTNU University Museum, and I'm the project manager for an archaeological investigation at Røsvatnet, a regulated lake connected to hydropower production, where we are using a multi-method approach for surveying. As you can see, we are several contributors to this presentation, and I, maybe the least technical of us, was stuck with the presentation today. Luckily, some are here today and can help me answer any questions about the different methods and results after the presentation. First, I will talk shortly about the background for this project. After World War II, the Norwegian government began investments in power-demanding industries that led to a large-scale hydropower regulations. This was necessary to be able to modernize larger geographical areas. The regulation of Røsvatnet in 1957 gave power to the iron and aluminium plants in the area, but also thousands of households. Unfortunately, they thought little about the consequences. There were few archaeological surveys before the damming. The water was raised 10 meters, 23 farms had to move, and 72 farms had lost arable land. So it had great consequences for people in the local community. In 2022, the government approved renewal of the license for hydropower production, but with new conditions. The power company, in this case Statkraft, had to pay a one-time fee to cover archaeological surveying and excavations in the regulated area, which gave us new chance for mitigating actions. The funds from the power company are regulated by Riksantikvaren, the Norwegian Directorate for Cultural Heritage, and there are some constraints related to the funding. Archaeological investigations can only take place in areas affected by the regulation. We cannot force the power company to drain the reservoir or keep the water level low. And to conduct surveys on land, we have a short window from when the snow or ice is gone in the spring before the reservoir is full of meltwater from the mountains. And the partners in the project are Nordland County Council, the Sami Parliament, and NTNU University Museum. Røsvatnet is located close to the Swedish border in the inner parts of Nordland County. And Røsvatnet and Tøstevatnet is part of the same reservoir. The graph shows the changes in the water level throughout the year, and the red line marks the water level before the regulation. As you can see, most years surveying near original water level will be difficult, but parts of the dammed up area can be dry around May or June. But the accessibility varies. Some years the water level is low when the snow is gone, and other years the reservoir is full when the snow has melted. Another problem is that it's a large area. The road doesn't go all the way around, and it takes almost 2.5 hours to drive from one end to another. The earliest known settlements from Inner Helgeland date back to the late Mesolithic, around 6,800 BC, and are sites linked to hunting, trapping, and fishing, maybe as sites in an annual cycle between the coast and inland, or as a part of a permanent inland population. But most of the material found at Røsvatnet is from the Neolithic, from around 4,000 BC onwards. They made artifacts of slate and later in quartz and quartzite, as you see there. And in this period, we can also find the first ceramics made of clay and asbestos. From the Iron Age, 500 BC to 1000 AD, there are a few cairns and burial mounds and some stray finds as iron axes from the Viking Age, probably connected to an agricultural population. But there are still traces of a nomadic hunting population in the mountains. Written sources show that we have indications of Sami settlement and resource exploitation in Helgeland around the year 1000. They also tell tales about Sami as about valuable trading partners, taxed people for the Norse Viking Age chieftains, and after a while to the king. In recent decades, a large number of finds have been collected by local people when the water was low. They have found examples of artifacts made of flint, slate, and quartzite, but also asbestos ceramics and a Bronze Age adze, as you see on the slide. Cultural heritage sites we expect to find on these projects are sites from the earliest settlers, quarries for raw materials, hunting and fishing traps, cairns and grain mounds, sites for production of coal, iron, and maybe bronze artifacts, and different Sami cultural heritage sites, such as hearths, turf huts, but also graves and ritual deposits. The constraints from funding, brief accessibility, and long distances make surveying difficult, and testing of new methods is not allowed in normal cultural heritage management and are in Norway mostly connected to research projects. But luckily, Riksantikvaren approves testing of new methods in projects connected to regulated power works. The purpose of choosing remote sensing methods at Røsvatnet are the mapping of the topography to provide a basis for planning fieldwork, to test which resolution requirements are needed for identification of visible structures and what types of structures we detect, map larger areas with potential just as a documentation, as the areas are not accessible for most of the year. And we also want to use the methods to try to understand the landscape changes, such as erosion and sedimentation. The methods we are using are LIDAR. It has a high precision, covers large areas, and penetrates vegetations. It provides elevation data, but it's big and not that flexible. As you can see, some areas we have scanned here, the North Bay and Tustvatnet. We use image-based modeling and aerial imagery with camera drone. The drone here is more small and more flexible, and the RGB data in particular has been important for verification of other datasets. We have invested in a multispectral RTK drone which gives RGB data, but also data about elevation and vegetation. We have used geophysics, such as electromagnetic induction and ground-penetrating radar. It provides information about conditions below the surface, not very area efficient and not that flexible, but are good for specific problems like erosion processes. We have used an unmanned otter with a multi-beam echo sounder, which can be used when the reservoir is full. It provides elevation data, but it's more expensive and less area efficient than the LIDAR. We also use traditional field methods. These are the areas we surveyed with the LIDAR, multi-beam echo sounder, and the geophysics. But as this is an aerial archaeological conference, we will focus on the results from the aerial and the marine surveys. Now I will show you some results from Strømmen, Hegemoen, and Stikkelvika. This is the stream between the Røsvatnet and Tustvatnet, and when we started surveying last year, the water level was already around 2 meters higher than before the regulation, and the LIDAR would not cover the area we were interested in. To get more complete picture of the topography before damming, we therefore used both LIDAR and multi-beam echo sounder in the same area. And this is the selection of the data from the multi-beam echo sounder. This is the same area with the LIDAR scanner. And this is with the both data sets. And you can see the data sets complement each other, and we have data of the topography down to the original water level. And both data sets have really, quite good resolution. When surveying the other side of the stream, the traditional way, we found several hearths and the red dots on the map. They are relatively small structures of stones with maximum 10 to 20 centimeters height. We cannot find the structures in the LIDAR dataset, as they are either too small or covered with sediments. We could use a higher resolution, but would then cover a smaller area. We do have some data from the multi-beam echo sounder, which not yet have been analyzed. Time will tell if this method will give us better results for detecting hearts. On the other hand, the LIDAR data is perfect for finding structures with more vertical height difference, like trapping pits or pitfalls for elk or reindeer. So you can see here some. At Hegmon, we used LIDAR and a camera drone. On the LIDAR dataset, we can see 2 foundations from the old farm that was in the area before the regulation. Skifta. Escape. Okay, it changed. Okay. When you see the aerial imagery, it's not, there is one more foundation. The fluctuation of the water through different seasons with the waves and the ice scraping on the sediments cause some structures, even large ones like these, to become covered by sediments and disappear. At Stikkelvika, we did traditional surveying and used a camera drone. And before we were there, they were registered 1 stone circle or a tent circle. With the aerial imagery, we found 2 more circles. The sedimentation had made some of the tent circles less visible from the ground. So the experiences so far, both LIDAR and multi-beam echo sounders are well suited for mapping topography and the cultural monuments of a certain size. The combination of LIDAR at low level, water level and multi-beam echo sounder at high water level complement each other and provide a complete picture of the lakebed topography. Both methods are well suited to covering large areas in a short time, but at the expense of resolution. Higher resolution comes at the expense of time, cost, and total area. And elevation data has great value, but works best in conjunction with aerial imagery. And the aerial imagery is an important source of information in its own, but it also plays a crucial role in the interpretation of digital elevation models. Cultural heritage sites that are less visible in the digital elevation models can be detected in aerial images with sufficient resolution. The challenges. Accessibility in regulated waters is very unpredictable and very time limited. There is little topographic information about the regulated areas to rely on. The use of unmanned surface vessels are more expensive and not as efficient as LIDAR, but it does not have the same time limits. The methods require technical skills and expertise, but typical for most archaeologists, like me. There are some difficulties regarding communicating archaeological requirements for data quality to third-party companies. And the methods are time-consuming, some are high-cost, and there is a vulnerability concerning keeping competence in-house. We wanted to use this multi-method approach to develop experience for new projects, as several regulated hydropower works face renewal of their conditions these days. There will be more such projects in our museum in the coming years. There are currently several similar projects in Norway, and the need to survey large areas within a time limit is important to all of these. It's also in other challenging environments like the Arctic areas could benefit from these results as well. And our feedback to tech developers and third-party companies could gradually lead to better data sets over time. Thank you for your attention.